Let's begin. Today's October 1st, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 1, 6, 15, 19, and 20. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our first digit, the triangle digit, and compares it to the number 1. So should the triangle value be equal to 1, or should it be greater than 1? Criteria card B will take a look at our middle digit, the square digit, and will let us know whether its value is an even digit or an odd digit. Criteria card C will take a look at our 3 digits, triangle, square, and circle, and will let us know which one is the absolute largest. Should triangle be the largest, should square be the largest, or should circle be the largest? Criteria card D will take a look at our first 2 digits, triangle and circle, add them up, and compare the sum to the number 6. So should the sum of the first 2 digits be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E will take a look at the 3-digit solution and will let us know a little bit about its structure, so to speak. One scenario is that the 3-digit code has no repetitions, meaning that all the digits are unique, as in the example 125, or it could be a double number, where there's a single digit repeated, as in the example 112, and finally, it could be a triple digit, where it's a single digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I want to test is I want to know a little bit about that middle digit. So let's go ahead and test criteria card B. Okay, so the Turing Machine approves of my choice. I did pick an odd one. So the Turing Machine confirms, yes, that middle digit is an odd digit. So let's go ahead and type that up in our notes in section B. And that is that square is an odd digit, and since it is odd, let's go ahead and cross out all of the evens. So crossing out the number 2 and the number 4. Okay, so the next thing I think I'd like to test is criteria card E. Okay, so this time the Turing Machine does not approve of my proposal. Notice that 314, all the digits are distinct, meaning there are no repetitions, but the Turing Machine does not approve of that. So we either have a double or a triple number. So let's go ahead and type that up in our notes in section E. And we'll say that the solution is a double or triple number. I apologize, there's a bit of a lag. Well, as that gets typed up, let's see. I think we can discount the possibility that it's a triple number since we do have an absolute largest digit. So that means that all 3 digits could not be the same. So let's go ahead and update the notes here. Let me correct some spelling. And let's also cross out the triple, since again there's no way it could be a triple number since we do have a largest digit. So that means that we do have a double. And again, notice that we do have this criteria card C, that's the largest. So that means that whatever is not coupled, it's not duplicated, that must be the largest digit. And let's see, what else could we test? So it would be interesting, triangle. If triangle were 1, then we know our pair would be 1. I think we can probably say that the pairs cannot be 5s, again, because if the pairs are 5, there's nothing bigger for the largest to be. So at least we know we can't have a pair of 5s. We could have an individual 5, that's fine, but not as a pair. Let's see, what else? I wonder. Let's see, if triangle were to be 1, then we know it'd be paired up. If not, then, well, I guess I wouldn't discount the fact that maybe triangle and square could be the pair of 1s. Yeah, I'm not sure. Let's go ahead and test criteria card D. Oh, wow. Okay, so the sum of the first 2 digits is less than 6. Very interesting. Well, in my proposal, 3 plus 1 is 4, and 4 is less than 6. So yeah, it's true that the sum of the first 2 digits is less than 6. So let's go ahead and type that up again. That would be section D. So we have triangle plus square, and that sum is less than 6. Okay, so what can we say about that? Well, we can say that neither triangle nor square could be 5s, since if you add 5 to even the smallest of 1, that's already 6. And obviously if you pick something bigger than 1, it'd go over 6. So yeah, so we know we can't have triangle or square be a 5. Okay. What else? Well, that does complete our round, or we did complete our 3 Turing tests. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So let's see, what else? So we did not test criteria card A, again comparing triangle to the number 1, and we did not test criteria card C, figuring out which one is the largest. Well, let's see. So if triangle were 4, the only thing you could add it to would be 1. And so yeah, I guess you could have 4, 1, 1. That's possible. Let's see. What else could we test? Well, let's see. Could triangle be 1? If triangle were 1, that means it's got to be paired up. So could it be 1, 1? I don't think it could be 1, 1, because then how would you choose your circle value? Obviously, circle would be the largest, but you have 4 choices, all larger than the pairs of 1s. So yeah, I don't think it's going to be triangle. Oh, that's interesting. Oh, but you could have 1, 3, 1. That's a possibility. So yeah, so triangle and square couldn't be paired up, but it could be that triangle and circle. What about triangle, square and circle? Those two, 1, 1. Well, again, I think you have too many choices, even though you are constrained to the sum being 6. 1 could be added to all of those. So it looks like if we're going to have a pair of 1s, it would have to be triangle and circle. So, you know what, let's see if listing them out is of any benefit. So we could have a solution of 1, 3, 1. You could have a pair of 2s, and then again 3. So that would be 2, 3, 2. What about a pair of 3s? Well, regardless, let's see if we have pair of 3s. So I don't think, again, triangle and square could be, well, triangle and square could not be both 3s because our sum has to be less. So it wouldn't be that. And yes, I don't think you can even have a pair of 3s because I think, again, you have to have a majority or a larger. So it can't be 3, 3 because of the sum, and it can't be 3 triangle and circle because there's nothing larger. And it could be square 3 and circle 3, but again, that would mean that triangle is 4. So yeah, I don't think you could have, I think this is it. I think that's it. You only have 1, 3, 1 and 2, 3, 2. So what's the distinction? The largest is still the middle square. The only exception is, well, is triangle 1 or 2. That looks like it's the only thing. Is that right? So it can't be 1, 1, triangle, square. Too many possibilities. Same thing for square and circle. Too many possibilities. 2, 3, 4. The only one that would work is 1, 3, 1. Okay. Going to pairs of 2s, the only thing that would work is 2, 3, 2. And yeah, I think you can't have, let's see, yeah, you can't have 3, 1, 3 because, again, you need a larger value. That doesn't work. That doesn't work. Yeah, I think that's it. So it's a matter of is triangle 1 or not. And I'm going to say not. So let's see, I'm going to choose 2, 3, 2 as my proposal. And so let's go ahead and test criteria card A. And okay, so it is incorrect. Triangle is a 1. So that means that 2, 3, 2 is not correct. We do have a 1 for triangle. So let me go ahead and cross out everything else for triangle. Okay, and again, it doesn't seem like it's 1, 1. Too many options for circle. I don't see anything that would help us choose. And obviously can't be square and circle because there's nothing else to choose from. So yeah, it looks like it's 1, 3, 1. And so let's go ahead, and I did not update my notes for A, and we'll say that again, triangle is equal to 1, since it did not agree with my 2, and 2 is greater than 1. So yeah, we can deduce its triangle equals 1. And here we'll state that we're going to deduce that square is the largest. And again, we are stating that the solution is 1. So let's go ahead and cross out the 1 for square. And then for circle, let's cross out everything else. All right, so it looks like our solution is 131. And just reviewing really quick, yes, triangle is 1. Square is odd, that's true. We've deduced its largest, sure. Sum of the first two is 4, which is less than 6. We do have a double, and that's it. So let's go confirm. So we got 131. Fantastic. Yes, that's the solution. So how did we do with the Turing machine? Well, we were able to deduce outright that square is the largest. So that means we only had to test, we only did 4 tests out of 5 criteria cards. That's awesome. Well, let's see. We did B, D, E in the first round, and we got B, D correct. E was incorrect, and A was incorrect. So let's go ahead and type that up. So B, D, E. E was incorrect, and we only had to test criteria card A in the second round. Fantastic. Look at that. We beat it by 2 questions. Well, definitely, picking the first 3 criteria cards really helped us sort of solidify what we were looking at. And we were fortunate that after, that first round, we really only had 2 to pick from. And it was a 50-50. So that really helped out. And of course, in both cases, square was the largest. So obviously very helpful. Well, how did you solve? Did you notice anything interesting in your solve that you'd like to share? Add those to the comments. If you liked the video, please do give it a thumbs up. And of course, if you don't want to miss out on any future videos, please hit subscribe to be notified. Well, until next time, have a great one.